Okay, in this problem, we're going to figure out the density of different atoms or molecules. And it says use the ideal gas law to find the density of helium gas at STP. So we have PV equals nRT. That's the ideal gas law. And then it's talking about helium. So if we think back or look at the periodic table for helium, we'll see it looks something like this. Okay, so do you see density anywhere? I'll give you a second. Do you see density? What was density? Density was D equals what? Mass over volume, right? Okay, do we see volume in the ideal gas law? And yeah, yep, exactly. It's right here. We have volume. But do we have mass? And if you're looking at it, you're probably not going to see it there. Do you have anything that is close to mass? All right, maybe. What about this N, right? That equals the number of moles. And how do you get number of moles? So like, let's look at that for a sec. Let's say we had 6 grams of helium, and we wanted to convert that into moles. Well, okay, so we would do this. And on the bottom, we would put grams, right? Because they need to cancel out. How many grams? And it would be 4.00 because that's the molecular mass, right? So this is the molecular mass. And then on the top would be 1 mole because that's what we're converting it into, right? So what is this? This was the given, right? This 6.00, that's given. And down here is the molecular mass. Well, if we think about what unit this is, it's in grams, right? And grams is just mass. Here it's molecular mass because, again, we're getting that from the periodic table. But what is moles? Well, moles is just taking the mass, dividing it by the molar mass. So N actually will equal M over mm. And again, this is mass, and then this one's molecular mass. So how does that change this equation? Well, it would change it to PV equals mRT over mm, which is just this part right here, right? Instead of saying N, we're saying it's M over mm. And the reason for that is so that we can get mass so we can figure out density. All right, which again, this is kind of long problem. So now we don't have just density, we have all of this stuff. So we need to rearrange this equation so that on one side you have density, or on one side you have m over v. So we need to do a little bit of algebra here. So we want to get v on the bottom because it's m divided by v, right? So we want to get it m over v like we have here. These are going to cancel out, all right? And we want this m and this v by themselves, which means all of this stuff needs to go to the other side, all right? So if you divide by RT on both sides, they'll cancel out. And then if you multiply by the molecular mass on both sides, that'll cancel out, all right? So now let's see what we have left. So on the right, actually, let's work on the left side. So on the left side here, we have mass. We have, I'm sorry, that's not mass, that's molecular mass. There should be 2 M's. Molecular mass times the pressure, and that's over R and T. and that equals m over v, which equals density. All right, that was exhausting, right? Okay, but that's how you figure it out. Now, let's say that you just want to memorize the equation, which is totally allowed. All right, so now instead of doing all of that, you can say, all right, density equals the molecular mass over the times the pressure over RT. Okay, so that's a new equation for this chapter here. All right, I just showed you how to derive it from the ideal gas law, but you don't need to do that every time. You can just memorize this equation. Okay, so molecular mass. What's the molecular mass of helium? It's 4.00. Molecular mass was grams per mole. Okay. And then the pressure. Well, it says everything's at STP, so the pressure is going to be 1 atm. Now, why are we using atm instead of like kilopascals? Great question. Because of the R. It's all of this, and then atm liters over K times mole. All right, so we need to cancel out the atm. That's why we used 1 atm. And the temperature is 273 Kelvin at STP. So all that's good. Next up, we need to start canceling some things out. Okay, so let's look and see what we can cancel out. First of all, there's atm up here. There's atm down here. There's Kelvin, and then the moles. Now the moles, again, it looks a little funky. Remember, when you're dividing and then dividing again, the moles here would get flipped all the way to the top. So it actually is up here. And this is divided by moles. So this mole and this mole would cancel out. All right, which is this mole. So that's going. All right. Next up, we have grams on top. And then we have that divided by liters. So our units left over are grams per liter, which is density, right? Because we have a mass divided by a volume. And then you just have to plug this into your calculator. So you would do 4 times 1, and then hit the equal button, divided by 0.0821, hit the enter button, and then divided by 273, hit the enter button, and that should give you the density of helium at STP with 3 sig figs. Now notice that there's no sig figs given, so actually the limiting sig fig here is because we round molecular mass always to 2 decimal places, that has 3 sig figs. So we're going to use that as our limiter. So it's going to be 0.178 grams per liter.